Okay, so on page 68, we just need to review some vocabulary words before we move on to the next section. The first thing that we need to talk about is the angle of elevation. And so if this is your horizontal, to elevate means to go up, so you're going to rotate up. And this right here is the angle of elevation. The next thing you need to talk about is the angle of depression. So if this is your horizontal, when you depress or when you go down, you're going to go down this way, or you could also, if you wanted to, go down this way, it doesn't matter, but this angle right here is the angle of depression. So you need to make sure you know where these are so that when you draw your picture, you have them in the right place. So now that we have that cleared up, we're going to do number 1. So take a second, and for 1, 2, and 3, go through and draw pictures, and we'll make sure we got them right. Okay, so on page 68, number 1 says that a surveyor is standing 115 feet from the base of the Washington Monument, so that's this length right here, and the angle of elevation, which is going to be this angle in here, is 78.3, and then we need to figure out how tall, my question mark over here, how tall is the monument? Well, in comparison to my in comparison to my angle, the question mark is opposite, and the 115 is adjacent, so we're going to use tangent. So tangent of 78.3 degrees equals my opposite, or my question mark, over my adjacent. You're going to multiply by your 115 to the other side, and then throw that in your calculator, and you'll get your answer. Okay, so for number 2, you're right here, and you're 200 yards away, and then from here, it's 400 yards on this bike path. They want you to find this theta, the acute angle in between. So in comparison to this theta that I drew, the 200 yards is the adjacent and the 400 is the hypotenuse. So we're going to use cosine. So cosine of theta is going to equal the adjacent over the hypotenuse. We don't even need a calculator for this one, because cosine of theta is going to equal 1/2. And theta, to be acute, for cosine to equal 1/2, is going to be at 60 degrees. So I need to make sure that you can do all your right triangle stuff. So if you want to practice 3, 4, 5, 6, and 7, you can, but you should be able to do all of those problems. So if you go to page 70, we're going to talk about bearings and directions. So the first part of page 70, let's look at the drawing. It says that you're south 35 degrees east. So what that means is you're going to start at south, which is right down here, and you're going to rotate 35 degrees towards east. And so you can see the examples for north 80 degrees west and north 45 east. So the first example says a ship leaves a port at noon and heads due west. So I'm going to leave my port. I'm going to head due west this way. Due west at 20 knots or 20 nautical miles per hour. And I get there at 2 p.m. Or at 2 p.m. I'm going to change my course. So that means I did this distance for 2 hours. So this is going to be a 40. So now I'm going to draw another pair of coordinate plane, because this right here is like my new origin where I am after I made my 40. And then once I get here, I change course. I'm going to start at north and go 54 degrees towards west. So I'm going to start at north and go 54 degrees this way. So this angle in here is 54 degrees. So to do a problem like this, the first thing that we can recognize is this length over here of my blue arrow, it's 20, because I only did this traveling for an hour. And I know this is a right angle. And what I'm looking for is the length from where I was back to where I am. So I'm looking for this green length over here, this X. Well, in our situation, what we have is we have a side, and we know this angle in here and the side. So if I want to find X, we're going to use the law of cosines. X squared equals 40 squared plus 20 squared minus 2 times 40. So 2 times 40 times my 20, and then I can't fit it in, but it should be cosine of 144. And I got the 144 because it's this 90 piece right here plus this 54 makes up that whole angle. So you should be able to enter that in the calculator and then square root it, and you'll get your x length. You can also set up the next one if you want, but let's look at the bottom of the page which says air navigation is measured in degrees clockwise from north. So if the word in the problem says a bearing, especially with air navigation, what that means is that I'm going to start at due north up here, and I'm going to rotate clockwise. So I'm going to rotate this way. So if I were to draw the first one at the bottom of the page, it says that an airplane is 125 miles north and 75 miles east of the airport. What's its final bearing to come directly back? Well, let's draw this. So my airplane is 125 north, so I'm going to go up 125, and I'm going to go east 75. So you're looking for this theta right here. So I went up 125, and I went over up here, 75. And then you can use tangent, and you'll be able to find your theta. So what I need you guys to do is you can go back, try the two problems on this page, but you need to remind Coach Guidry, pretty please, to do in class page 70, number 2 on Monday. Hopefully this helps you kind of get through some definitions and whatnot so you are ready for your test on Tuesday. If you have any questions, make sure you email them, you've checked your grades online, and that you have your homework done for Monday. If you're looking at number 2, an observer in a lighthouse is 300 feet above sea level and observes 2 ships offshore. The angles of depression are these two things, 4 degrees and 6.5 degrees. How far apart are the ships?